Can you tell me whatever you see?
There are a lot of fallen leaves on the ground, and it looks like it's autumn.
Let's build a live voice and vision agent in Python that can see your surroundings and respond to your questions in real time. We'll use the OpenAI Realtime API, which has a built-in support for WebRTC, to deliver the live audio. For the agent to have a video call with you, we will use Vision Agents. Vision Agents is an open-source video AI framework for building voice and video applications. It is built and maintained by the team at Stream. For a step-by-step guide on how to get started with Vision Agents, you can check the YouTube video Vision Agents Quick Start in Python. Similar to the Gemini Live API, the OpenAI Realtime API allows developers to build low-latency multimodal AI applications. You can use the API to build low-latency communications with modules that support speech-to-speech interactions and multimodal inputs such as images, audio, and text. You can also use the API for real-time audio transcription. To begin building our Gemini Live clone in Python, I want us to experience and have a look at how the Gemini Live on iOS works. Can you tell me whatever you see?
There are a lot of fallen leaves on the ground, and it looks like it's autumn. The leaves are mostly brown and yellow. There's a leafless tree in the middle of the yard, and a house is visible in the background. The sky is overcast.
Let's look at how the Gemini Live clone we want to build works. For the agent to see our surroundings, it will take an audio input and the camera feed from users through Stream Video. When using Vision Agents, Stream Video is the default transport. You can also use a custom transport implementation. The user's voice input and camera feed will be sent to OpenAI for real-time transcription and video processing. Since the OpenAI API supports two use, you can also perform function calls, web search, and code execution as demonstrated in this image. Eventually, the agent's voice output is what the user will hear while describing whatever it sees in a particular surrounding. Vision Agents is available on GitHub, so visit this repo and give it a star. You can now launch your favorite code editor and let's get started. For this example, we are going to use Cursor. In Cursor, I have already opened an empty directory, so let's bring the integrated terminal with Ctrl and backtick. To create the Gemini Live clone in Python, we need to complete a few steps. First, we need to initialize a Python project using UV. You can also use pip as your package manager. However, we recommend using UV. Next, we install the Vision Agents package from PyP and OpenAI Realtime API as a dependency. Finally, we configure the voice agent in Python to launch a web video call UI powered by Stream Video, allowing you to speak with it in real time. We begin by initializing a new Python project with UV using the command UV init. Shortly, that creates a new Python project with all these files. To be able to run the project, we need two API credentials, one from Stream and one from OpenAI. So let's add a .env file. In the .env file, I will paste the following credentials. You will need to enter your OpenAI API key, Stream API key, and secret. Then we use this base URL. You will find it in the description of the video. To get an API key from Stream, you should visit the Stream homepage and click the button Start Coding Free, or go to the top right and click the same button. After creating an account, you should add a new app to obtain an API key and secret. For an OpenAI API key, you should visit platform.openai and log into your account. So these are the two API credentials you will need for this project. After you obtain the credentials, you should add them here. You can also export them in the terminal using the export command. I have already stored these credentials in my shell profile, so I will not add them in the .env file. Let's also add a new markdown file to give the agent detailed instructions. In our agent instructions.md, let's paste this text. We can also add the same instructions in the agent's definition in main.py. However, if you have too much text instructions, that will keep the code very long, so it is good to keep it in a separate markdown file. When we configure the agent in main.py, we will need to reference agent instructions.md, so let's remove everything here in main.py and start coding. After initializing a new Python project with UV, and also setting up your API credentials. The next thing to do is to install Vision Agents. So let's use the command add Vision Agents. So within a short time, you have noticed we have been able to fetch the package from PyP and install it. Once you install the Vision Agents package with add Vision Agents, only the core Vision Agents SDK will be installed. So we need to install plugins separately. I'll clear everything in the terminal and add this command. add Vision Agents, GetStream and OpenAI. The GetStream plugin will provide the audio and video transport. Then we use one of the real-time models from OpenAI. I will press the return key to install them. We have now initialized a Python project and also installed Vision Agents as well as its plugins. We can now go ahead and configure the voice agent in main.py. I will add the following imports. We have async IO for asynchronous processing and UUID4 for generating random unique identifiers. That is a unique call ID for connecting to video call. Next, we add the required Vision Agent imports. User, Agents, OpenAI, and GetStream. Agents is the core module of the framework. OpenAI provides the real-time API for voice AI. Then we use GetStream to provide the edge infrastructure for real-time audio and video communication. Next, we will define an async main function and create a new agent. To create a new agent, we use the SDK's agent class and give it the following parameters. So basically, you create an agent and configure it for real-time voice interaction. We use Stream's Global Edge Network for low-latency real-time communication. Next, we define the agent's identity as a user in the call by adding a display name for the agent and also a unique ID. Next, we add the instructions we want to use for the agent. In this example, we are loading the file agentinstructions.md. That is the instructions we added earlier. So we add the instructions parameter and read the markdown file agentinstructions.md. The next parameter is optional processors for audio and video processing. Processors are useful if you want to create physical and vision AI applications that require real-time video processing. To integrate processors in your AI application, you can use models from leading providers like RoboFlow, Ultralytics, and Moondream. If you are building a robotic application, you can also use a model like Gemini Robotics 1.5. Next, we add a LLM parameter and use the OpenAI Realtime API for end-to-end speech-to-speech interaction. So this will handle voice input and output automatically, so there is no need for a separate text-to-speech, speech-to-text, or voice activity detection model. The OpenAI Realtime API handles speech recognition, speech synthesis, and voice activity detection with a single audio generation model. Our next step is to register the agent as a valid user in the system. Then, we create a new video call with the unique call ID by specifying the call type as default. You can use the default call type in Stream Video for building video conferencing applications. After creating a new video call, we should launch a browser-based demo UI so that we can test the voice agent interactively. Finally, we will join the agent to the video call. So we use the join method to enter the call and keep the agent running. Then we clean up and finalize the agent session. This is all we need to do to build our Gemini Live clone in Python, an agent that can hear and see our environment and respond to questions. To demo what we have done so far, let's go to the terminal and run our main.py with UV. Okay, just tell me whatever you see.
Sure. I see you sitting in front of a microphone, wearing a dark hoodie with a logo on it. There's a painting or picture behind you with some leaves or branches. The lighting in the room
What
is
is written
soft
in
and
it?
even. Sure. I see that you're wearing a black hoodie with the word stream on it, and there's a logo above the text. You're sitting in front of a simple background
What do you
with a
see
piece
now?
of art. I see you're holding a white bottle. It looks sleek and has a small logo near the bottom.
That is all I have for you in this video. Vision Agents makes it simple to combine real-time video, speech, and LLMs into interactive AI experiences. Out of the box, it supports real-time speech-to-speech models from OpenAI and Gemini. Using Vision Agents, you can also integrate custom voice pipelines for text-to-speech and speech-to-text, using leading providers like Cartesia, 11 Labs, DeepGram, and more. If you want to build physical and vision agents, you can use models from leading providers like Ultralytics, RoboFlow, and Moondream. To learn more about vision agents, you can join the Discord community, read the docs to explore advanced use cases, and test the demo apps. From the documentation, you will also discover how to extend the video AI framework with third-party plugins. Finally, the companion YouTube video is your step-by-step guide in getting started with vision agents.